Hi folks, hope all is well today. Just doing a little video tutorial here on a question from the Graphics and Design Communication book by David Anderson. Now this question itself is on page 284 of that book and it's question 9, and the question is based on cycloids. Alright, you're basically asked here, guys, I have the question set out on screen as you see, and you're told the circle rolls clockwise along the given line without slipping. Alright, and basically we're asked to plot the locus of the point P for that movement as it rotates around here. And of course the locus of that would be known as a cycloid. Alright, so the first thing we're going to do here, guys, for this, we have our circle, we have our point P, and we have this line set up as you see there with the information given in the question. So the next thing I'm going to do is going to be one full revolution, and I'm just going to label our points from 1 to 12 around the circle, and I'm going to start here at number 1 after P because that's the first point that's going to hit the line as it's rolling. Alright, so I have them already marked out, so I'll just label them here. So that makes it easier, first of all, breaking it down into 12 steps with the full circle, and so on. Now, I suppose key things to remember here, guys, is that the height of our center point here, isn't going to change in relation to the line or the ground that it's rolling on. So I'm just going to carry that height across, first of all, bring that height across, and as it takes a turn down here, it's going to come parallel to that line as well at the same height. Okay, I'm just going to come off there, going to measure off that height 90 degrees to it, and you'll see here the height there is 26 millimeters, and it'll be out 26 millimeters 90 degrees here as well. So just going to mark that in first of all to highlight the center line there, or the height of the center line as it's passing through its motion. And just highlight that there just to make it a bit clearer. Okay, and on that center line, guys, we're going to have to mark all our new center points. And what I mean by that is, as that wheel rolls around on the ground, we call it, this center point is going to move into new positions at each step as it moves along. Alright, and the way we do that is, I'm going to do that first of all. The way we do that is we get our distance of one of the intervals, if you like, or sectors in the circle. So that distance here, I'm going to take from P to 1. It's the same from 2 to 3 and so on. Alright, we have 12 steps, so I'm going to step that out. 1, 2, all the way up as far as 12. Now, you can see here, I'll just label those. That'll be 1, 2, 3, 4, 6, 7. So you can see, guys, I'm only getting 7 full units there on the first line before we come to that turn. Alright, and what we must do there is we're going to take this distance from 7 to the corner. I'm going to call it X. Alright, going to take that distance there from 7 to X. Alright, and I'm going to come up on the wheel here to number 7, and I'm going to, towards number 8, I'm going to mark out that X. Okay, that's my X here, as you can see it. And what I'm going to do then is I'm going to take a distance from X, very small here. Take your distance from X to number 8. Alright, so X to 8, if you can see that. X to number 8, and I'm going to mark that from point X on the ground line around the corner here. Okay, and that's going to give you your number 8 there. Alright, quite close to X. And from there, guys, then go back, get your base again of the full sector, and we're going to carry on from number 8, 9, 10, 11, and 12. So they are marked in there, 9, 10, 11, and 12. So what I'm going to do from them, guys, then I'm going to project them out at 90 degrees to the ground line. I'm going to project those guys up, and they'll in turn they will give me the new. I'll put them in green. They will give me the new center points. Okay, so for each step we move on that wheel, you'll have a new position for the center point. And I'm just going to mark all them out first, guys. I like to do that first of all. Get those marked out, and then you can get down to the, I suppose, the nitty-gritty of that question. All right. When you come to X here as well, you'll bring it straight up. And as you can see here, out at 90 degrees as well. And I'll explain that in a few minutes when we get to it. So what we have now is all our center points. I'll just mark in a few of them here. Well, I won't. You could label those guys C1, C2, C3, and so on up as far as C12 for the new position of the center point each time. But it's adding extra text, I suppose, and it's going to get more muddled up then doing it that way. But you can do it that way to keep track of it and make sure you don't get confused. All right. So a handy thing here, guys, is to have two compasses, even a good one and one of those cheap ones if you like, and I'll show you why in a minute. Okay, what we're going to do here, in order to plot the movement of point P after, I'm calling these a step. Okay, so after each step of movement, you want to plot the point P in its new position. All right, and to do this, we're going to use a method of triangulation. What I mean by a method of triangulation is we're taking measurements here from center point to P, and we're taking measurements from 1 to P. Okay, so you're kind of forming a triangle there with each movement, if you like. And if you can imagine, that triangle is kind of rotating, if you like, as the wheel is moving. All right. So the key measurements to take here, guys, I'm going to use this compass here to take this measurement. Now, the reason I have a second compass, it can speed things up. All right, because with each movement, we're going to need that distance here from the center point to P. All right. So what I'm going to do here on my new center point, guys, just going to set the compass there, and I'm going to swing an arc from the new center point to that radius. My second compass, you can do this with one compass, but it's just handy to have two of them. My second one, after that, from on the circle number 1, okay, to P, you're taking that distance, and now you're putting it in this new position, because this number 1 will roll down onto the ground. I'm going to swing an arc there, and that's giving you your point P in this new position. Okay, but that's giving you point P there. I'll just mark it as a dot in its new position, and I'm going to call that P1. Same thing again, and again just double check, especially if it's a cheaper compass, your radius for center point 2. Swing your arc. Again, we're using the method of triangulation. Swing that arc, and this time, guys, you're taking your dimension from number 2 on the circle to P. Okay, because at that distance we're working off number 2 now, and we're basically doing that 12 times. Okay, so number 2 on the circle, and number 2, when it's rolling, the circle is going to come down onto this point. So from the baseline number 2, swing your arc again, and that there will give you P2. Alright, so once you get one or two of these done, guys, it is quite repetitive. And again, number 3, moving back center point to P, from your center point number 3. Now don't get mixed up with these. Swing an arc. This time, remember, you're taking a measurement from number 3 to point P, because that's the distance from 3 to point P when you move the wheel at any stage. Okay, so 3 down here on the baseline to point P, and that gives you P3. So I'm going to follow suit, guys, for the rest of that question. Again, go through it one last time. Center point to P, we're on number 4 now. Swing an arc from that center point. Take your distance from point 4 to P, and swing it from point 4 on the baseline across the last arc, and that's giving you P4. Okay, so I'll carry on for the next few. I'll do that until we get up as far as the corner here. Now just in relation to point 6 here, guys, so when I marked my center point 6, swung an arc, right, keep in mind if I am taking my distance from 6 here to P, alright, it's not going to give you much accuracy there as you swing the arc, because it looks like the arc's going the same direction, okay? But if you look back here, point 6, to get from point 6 to P, you're coming straight through that center point, alright? So what you can do in that case is from point 6 in the ground line, straight through your new center point, and where it crosses that arc that you've drawn, that's giving you P6 here, okay? And it's important to label P4, P5, P6, guys, all your points as they move, because when you're taking your next measurement, it's very easy to forget which number you're on. And if you see the previous one there, P6 done, you know now that you're moving on to number 7. Okay, so the next step here, I've got up as far as number 7. That's all my full steps or full units of movement, if you like. So what's happening here is your circle now is going to move into this position. I'll just draw it, your wheel, I should say, when it moves on to point X, just to explain what happens. Okay, so we've moved on to point 7. So now the wheel at the same radius moves on to center point X, we'll say. Okay, that's going to be it there in that center point. Alright, so I'm going to do the same thing here, because it's going to take a bit of a turn here in a second as regards the direction of that wheel. So that's your center point X. Okay, so that's essentially my arc done, guys, from the center point, from the X, we'll say center point. That's my arc done there. I just drew in the full circle this time. Now I'm going to take the distance from point X. So if you remember a few minutes ago, we put that distance on the wheel, point X. Take the distance there to P, and I'm going to come along here from X, swing that arc across the previous arc or circle I did in this case, and that gives me point, I'm going to call it PX. So you have your path so far of your cycloid done out there, just to draw the cycloid itself. Alright, so what's happening here, guys, on the turn, you must extend out your center point X here as well, or X1 we'll call it. Okay, I'll just label those two. So we'll say this one, center point X, center point X1. Right, the reason that, sorry, X1 and X2. The reason there's two X center points, if you like, is because for this one, guys, here, when the wheel is moving, for the next step, when it moves on to number 8, the actual point here of the wheel that sits on X, that remains on point X. Okay, what happens is your center point rotates around to a new position until the center line is perpendicular there off the ground. Alright, so same thing again from point X here. Just going to take the radius of the circle. So I'll just draw it in position here from this one as well. So what's happening is it's going to roll around the corner. Alright, and that's essentially the arc, the radius that we've been swinging from the beginning. And again, going to take the distance, sorry, from X to P. That's the same distance you're taking again, from X to P, and again put that on X, swing it through the arc. Okay, and now that gives you what I'm going to call PX1. PX1 over here and PX2. Okay, so it's basically swinging around there, then stationary on the point X, and this is it now in its new position. So now the wheel is ready to roll down along these points as you see it here. So again, not to be repetitive, guys, I'm going back starting on number 8. I'm going to carry on through to number 12 like we have with these plotting the locus of the point here to show you the final, I suppose, landing place of the point P. Okay guys, so that's it done up as far as P11, so plotted the point as normal from there around. And P12 then, the last one, it's actually on point 12 here, because if you look here on the wheel, point P is on P12 if you like. So when that comes down, hits the ground level, that's your cycloid done there, and now it'll just draw it in place there from dot to dot, basically, or point to point. That's the path, or the locus of point P throughout that motion. There you go guys, that's point P plotted throughout that motion, and as you see it in place there. So remember, you're taking your distances from your center point to P each time, marking it off from the new center points, and you're taking your distance from the relevant point on the wheel, so number 1 or number 2 and so on, to point P, and you're using that method of triangulation.